Everyone, in this video we're going to talk about adding or subtracting matrices and multiplying matrices. We'll spend the bulk of the time talking about multiplying matrices because to add matrices, it's very simple. You just take each value of each corresponding location, add them together. See these to get 1 plus 0, 1. 0 plus 4, 4. 2 plus 1, 3. 3 plus 2, 5. 1 plus 5, 6. 4 plus 3, 7. There we go. So if this was like matrix A and this was matrix B, we've just found matrix A plus matrix B. Pretty simple. And if you subtracted two matrices, it'd be very similar. I just want to point out that this right here, we talk about the dimensions of the matrix. This is a 2 by 3 matrix. It's got 2 rows and it's got 3 columns. All right, this is also a 2 by 3 matrix. 2 by 3. And sure enough, if you add a 2 by 3 matrix to a 2 by 3 matrix, the resulting matrix is 2 by 3. Same thing with subtraction. And I don't have to do that. I know you understand that. But let's talk about multiplying matrices. Okay? So we're going to multiply matrix A times matrix B. All right? Yeah, I can put like a star here, a multiplication sign. The answer? You can't. You can't. Not in this example. See, in order to multiply matrices, the inner dimensions must be the same. All right? If you notice right here, this is a 3, and that's a 2. So yeah, this is R and this is C, and this was R and this was C. Then the columns, number of columns in the first matrix must be equal to the number of rows in the second matrix. These have to be the same, and if they're not the same, you can't multiply the matrices. So I'll make another example, but you can't multiply those. All right, so how about this? Get this out of the way. Yeah. Let's pretend matrix B had another row in here. 1, 2, 4. How about that? All right. Now, matrix B is bigger. Let's look at the dimensions of these two matrices. This is a 2 by 3. 2 rows, 3 columns. This has 3 rows and 3 columns, right? RC. RC. Can we multiply these? Yes, because the inner indices are the same. The inner dimensions. Now, what will this resulting matrix look like? Look at the outer dimensions. See, that's a 2 and that's a 3? That tells you dimensions of the resulting matrix. These outer numbers. If you can multiply them, that will be the dimensions of the outer of the resulting matrix. The outer dimensions. So it's going to be 2 by 3. So hey, you know what? I'll just make a couple dashes here. Right, with 2 rows and 3 columns. And let's find all these numbers. All right. Now to start out with, you don't have to go in order. Yeah, for instance, let's find this number right here. I'll put a little ping. Let's find that number right there. How do you do that when you multiply matrices? Ask yourself this question. What row is this located in? Notice it's in row 2. Go to the first matrix, we're going to use row 2. Second question, what column is this located in? It's located in column 2. Go to the second matrix and circle column 2. These are the values you're going to use to produce that number. What I need you to do is take this 314 and tilt it up like that. I'll write it down right here. So 3, 1, 4. Line it up right next to that 4, 5, 2. And you multiply those. You multiply those, you multiply those. 3 times 4 is 12. 1 times 5 is 5. 4 times 2 is 8. And you'll just add these 3 values together. And 12 plus 5 is 17, plus 8 is 25. Everyone, we found this number. It may seem like a lot, but it's not that bad. We'll just do it over and over, and we'll finish up this matrix. That's a 25. All right, so you don't have to go in order. Let's see, let's get this number next, okay? It's out of the way. Let's get that number, okay. We're going to find this number right here. row is it in? Row 1. Oh, excuse me, row 2. It's in row 2. What column is it in? It's in column 1. So let me get this off here. Get that out of there. And we're going to use this column. Alright, take this, tilt it up. What do you got? You got a 3 and a 1 and a 4. And you got a 0 and a 2 and a 1. Multiply these, multiply these, multiply these, and then add down. If you can do this mentally, it goes a lot faster. 3 times 0 is 0, 1 times 2 is 2, 4 times 1 is 4, 0 plus 2 plus 4 is 6. And we'll just keep doing this for each one of the values. You don't have to go in order. Right? You don't have to start at the top left and go like that. You can if you want. We'll finish this out. Yeah, let's get this one over here. All right, ask yourself that question. What row is this in? Row 2. So you always use the row from the first matrix and you use a column from the second matrix. All right, so we're looking for this value right here, bing, then we need to use that column. But this is located in the second row, that's why I'm using row 2. Take this row, tilt it up, you got a 3, a 1, a 4, and you got a 1, a 3, a 4. Multiply these, multiply these, multiply these. 3, 3, 16. 6 plus 16 is 22. And we'll just continue this process. Now we'll get the values in row 1. Of course, we're going to use row 1 there, right? So, this time I'll go a lot faster. Let's just do it mentally. Yeah, let's just do it mentally. We're definitely going to use row 1, because these values are in row 1. But each one of these will change, so I'll just get this out of the way. Get this out of the way, let's do this mentally. Alright, to get this value, use row 1 and use column 1. 1 times 0 plus 0 times 0 plus 2, that's a 2. For this value, use this row and use this column. 1 times 4 plus 0 times 5 plus 2 times 2, 4 plus 4, 8. And lastly, for this one, use this one, this row, and this column. Remember, this row would tilt right up like this. And we get 1 times 1, which is 1, plus 0 times 3, plus 2 times 4. So you get 1 plus 0 plus 8, which is 9. That's multiplying matrices. This is AB. Matrix A times matrix B. Now, before I leave this, does matrix A times matrix B always equal matrix B times matrix A? Right? Does that really work? You know, in the real number system, 2 times 3 equals 3 times 2. Does that work in matrix multiplication? Well, in this example, you'll see the answer is no. It's real simple. 2 by 3 times a 3 by 3, we got a result. Well, if you did matrix B times matrix A, wouldn't you have a 3 by 3? Multiplied to a 2 by 3, right? Isn't that what would be going on? And can you do that? Not here, because the inner indices, those inner dimensions, aren't equal. You can't multiply B times A in this example. So, the answer to that question is no. In matrix multiplication, matrix A times matrix B does not always equal matrix B times matrix A. Okay? So, that's it.